Hello, welcome in this science video. We will present experiment falling down, inspired by Galileo Galilei. We will observe the movement of two plastic bottles with different mass and weight as they roll through the Earth's atmosphere in order to understand how gravity acts objects.
Have you ever wondered if an object with more weight or a greater amount of mass falls faster than a lighter one? For many years, people believed that heavier objects fall faster. However, this experiment allows us to measure and observe whether that idea is true under normal conditions at sea level.
The objective of the experiment is demonstrate that two objects with different mass, volume, and weight can fall at the same time when they drop from the same height, as long air resistance does not significantly affect their movement.
For this experiment, we used two plastic bottles. One bottle is filled with water, which increases the amount of material inside, its mass, density, and weight. The other bottle is left empty and contains air, which is a mixture of gases such as oxygen and carbon dioxide. Both bottles are held at the same height and then dropped at the same time. We make sure they fall onto a soft surface so we can clearly observe their movement as they fall downwards.
When we perform the experiment, we observe that both balls reach the ground at almost the same time. The average time of fall is very similar, even though one ball has more mass and weight than the other. The result shows that the force of gravity has the same intensity on both objects, and that increasing or decreasing weight does not significantly change the falling speed.
This experiment is based on the principle of free fall. Gravity is a natural force studied in science that causes objects to fall towards the earth. As objects move through the atmosphere, air creates pressure and resistance. This resistance can diminish the speed of falling objects, especially those with large volume or low density. However, in this experiment, air resistance is small and does not strongly affect the result. The acceleration due to gravity is approximately 9.8 meters per second squared, regardless of mass or weight, and is not inversely proportional to them.
This principle can also be observed in the life and science. For example, rain falling from the sky shows how gravity works. Raindrops fall due to gravity not because of their weight. Large drops might fall singular faster because in resistance effect stimulates but gravity accelerates. Hal drop in the same way. Another clear example occurred on the moon where there is no atmosphere. An astronaut dropped faster and both touched the surface at the same time. This principle is also applied in preparatory descent sport and motion studies.
For our Falcon, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
And in conclusion, this experiment demonstrates that the speed at which an object falls does not depend on its weight, but on the force of gravity. By observing and measuring this experiment, we learn that mass, volume, and air resistance only have a small effect under normal conditions.
We invite you to explore more experiments like this and continue learning about science and motion.